Welcome to the third pillar of object-oriented programming, polymorphism. This may be the most powerful and often confusing concept, but it is essential for writing flexible, extensible code in any language. The word polymorphism literally means many forms. 1. Definition of polymorphism. In OOP, polymorphism is the ability of an object, variable, or function to take on multiple forms or types. Specifically, it allows a single interface to be used for different underlying data types. This means different objects can respond to the same message or method call in their own, distinct ways. 2. Simple example, the plus operator. The simplest form of polymorphism you've already used is the addition operator, plus. When used with numbers, it performs addition. But when used with strings, it performs concatenation. The plus operator has many forms, and its behavior depends on the type of data it operates on. This is an example of operator overloading, which we maybe will see soon. 3. Types of polymorphism. While polymorphism is a broad term, we will focus on three main types within Python. First, duck typing, which is Python's dynamic core concept. Second, operator overloading, which we just mentioned. And third, runtime polymorphism, achieved through method overriding and inheritance, which you already have some experience with. 4. Introduction to duck typing. Python's flexibility means we don't care about the object's formal class type. We only care about whether it can perform the action we need. The famous saying is, if it walks like a duck and it quacks like a duck, then it must be a duck. This principle is known as duck typing, and it is the foundation of polymorphism in Python. To summarize, polymorphism is essential for interchangeable components. Duck typing means if it has the method I need, I can use it, regardless of its class hierarchy. Join me in Lecture 19.02, Duck Typing. See you there.